All right, these are the office hours for November 8th. The only question I've gotten so far has been on problem 1, so I'll just kind of go over that. So specifically, problem 1's part D and E. Dealing with zero crossings, or peak values. And so, first, let me generalize this. So if we have some V of t, or I of t, doesn't matter, which is going to be some V naught cosine of omega t plus theta, then this thing, if we graph it, is going to, in general, look something like this, where the peaks are going to correspond to where this argument, I'm going to call it A, has a value of 2 pi, 4 pi, 6 pi, 0, minus 2 pi, and so on. So I'll tell you where the peaks are located. The zero crossings are going to be where this argument A is pi over 2, 3 pi over 2, 5 pi over 2, and if we go the other way, minus pi over 2, minus 3 pi over 2, and so on. That's the issue with the cosine. That's how the cosine works. And so we need to find the time value where corresponding to the first one once this occurs. So I'm going to start with the zero crossing one. So we're interested in when omega t plus theta is going to be an odd multiple of pi over 2. Well, how do we get an odd multiple? Well, we have our pi over 2 here, and now we need an odd number. Well, if I have 2 times n, where n is any integer, plus 1, or minus 1, doesn't matter, this number here is always going to be odd. So if n is 0, I get pi over 2. If n is 1, I get 3 pi over 2. If n is minus 1, then I get minus 2 plus 1, that's minus 1, so that would be minus 3 pi over 2. So any value of n, so n equals minus 5, minus 4, minus 3, minus 2, all the way up to 0, 1, 2, 3, any integer, this will correspond to a zero crossing. So I need to find the first one for time greater than 0. Well, move things to the other side, that means my t, call it t naught, for all the zero crossings is going to be pi over 2 times 2n plus 1 minus theta, that whole argument, divided by omega. And I know, in each theta and omega, so as my phase changes, this is going to move around, this will give me where the location of those zero crossings. And so now I have to test it. So I plug in time equal to, say, minus 1. Well, does that give me a t naught greater than 0? Well, then I can try t naught. If it does, then I try n minus 2. Does that give me a t naught greater than 0? And so on. Or I can increase it. If n equals 0, n equals 1, n equals 2, so on. And so by testing different values of n, I'll be able to identify all the different zero crossings, and I'll find the one that is closest to time equal to 0, but greater than it. And we can do the same thing then for the peak values. So now I'm interested in when omega t plus theta is going to be an even multiple of 2 pi. Well, the easiest way to do that is 2 times n times pi. So if n is 0, it's 0. If it's 1, it's 2 pi. If it's 2, it's 4 pi, and so on. And that corresponds to the positive peaks. And so my t peak then is going to correspond to 2n pi for all the different values of n minus theta all over omega. And so now I need to test my different values of n. Plug in 0, plug in 1, plug in minus 1, so on, and find the value that is closest to time greater than 0, but greater than. And so that's how you would solve problem 1 for the zero crossing and the peaks.